Now we are going to see about the final welding process called soldering and brazing. So hope you have come across the word soldering. So soldering and brazing also a type of a permanent joint to bond the metal pieces. So soldering and the brazing process lies somewhere between the fusion welding and solid state welding. So you know what is fusion welding. Fusion welding is nothing but the type of a welding which comes under the arc welding process and all. It's a kind of a fusion welding, and solid state welding is nothing but the kind of a resistance welding what we have seen now, the seam welding, spot welding, that and all. A solid state welding where we don't melt any base material or a filler material, whereas in the fusion welding we will try to melt the electrode and flux. So this soldering and brazing is in between to these two types of a welding process. So first we shall see about what is soldering. So the joining of metal using a filler material of lower melting point than that of the parent metal to be joined. Okay, so usually the melting temperature for the soldering will be below 450 degrees Celsius, right? So it will be generally lower at a melting point than compared to the base material what we are trying to weld. So coming to the process, we have three steps. You know, you have seen in the lot of electronic shops how the soldering process has been happen. So the same thing is explained here. So initially we have to heat both items by applying the soldering iron, that means the tip to the copper pad and the component lead. Okay, so that is a filler rod. You know that, one second. So this is the filler rod. It is initially made up of lead, and this is the solder iron. Right. So we supposed to continue heating and apply a few millimeter of solder on the surface where we have to weld. So remove the iron and allow the solder joint to be naturally cooled. It takes only a second or 2 seconds to make the perfect joints, which should appear shiny. So always the since we are using the lead and the tin as a solder, usually that portion will be very shiny, right? So based on that structure, we can able to get to know that so the welding is good or bad. So here I have projected the difference between the good and bad soldering. So the very left hand side image shows the perfect welding, perfect soldering. Okay, so that will be clean and the surface will be very smooth. You can able to see it is more shiny and also forms a concave fillet. You can able to see the shape. Okay, so it will be a kind of a concave fillet. So if the soldering comes under these three categories, it will be a good soldering method. So coming to the bad soldering, so that is the middle one on the left hand side image. So generally it will be a kind of a rough type of a surface. You can able to see some spatters also formed on the surface. Okay, and also not properly soldered. So you can able to see the soldering is not properly like this, and here it was deposited much amount of solder. Here there is no solder, and also the fluxes are open to the air. So these are the kind of a bad soldering. Okay, this is the difference between the good and bad soldering. Coming to the tools which was used for the soldering, there are a number of tools. So basically they will use 3 to 4 tools, but perfectly with a proper WPS you have to use about 10 tools. So starts from vise. This is the vise. So that vise is used to hold the PCB, printed circuit board, or any other workpiece what we are trying to solder. And next one is safety glass, because the fumes will be generated. Since the solder is made up of lead and tin, it will produce some toxic gas, so it should not affect our eyes, so that we have to use the safety glasses. And solder sucker, so it is nothing but if you are putting some extra solder over the surface, we have to remove that. So in the bare hand we should not remove that, so that we are having some separate tools, that is nothing but the solder sucker. And next one is solder tool, which is used to perfectly place the solder on the surface. and we are having two cutters. One is a diagonal cutter and nose pillar, and it is used to reshape the pins. You will have that resistor and all, no? So you will insert the resistor on the holes which was there in the PCB. If the leg is very big, we have to cut that, right? So to cut that or to shape that, we will use these two types of a cutter. One is diagonal cutter, and next one is solder peeler, noise peeler. And the seventh one is nothing but the solder, what we are used to weld. So you can able to see it is will be in the form of a wire. Okay, and the next one is solder wick, which is used to preheat that. And the next one is damp sponge. So usually you can able to see once the solder was happened over the surface, then the man will take that ion pin. So this is the solder ion. So he will take that solder ion from the PCB and keep in the sponge. That sponge is nothing but the damp sponge, which is used to clean the surface for the next set of soldering. So these are the 10 different solder tools which was used generally. And what is solder? Right, so solder is a very important portion in the soldering process. It's nothing but a small wire, right? Solder is nothing but an alloy. Generally, it's an alloy you can able to see in shops. So it is made up of a tin and lead. So you know that the tin and lead are very amorphous surface, and the melting point is very less for this both the metals. So the solder generally used for electronic purpose or frequently made up of 60-40 solder. So what is that 60-40 means? 63% of tin will be there and 37% of lead will be there, right? So that is an alloy of a solder. So this 60-40 solder melts at 361 degree Fahrenheit. So you know that soldering will be done less than 450 degree Fahrenheit. Okay, so it will be generally melted at 361 degree Fahrenheit. So multi-core solder is generally used for many electrical works. Okay, so other than the tin and lead, we will have some other alloys. So it will be used for electrical works. So hope you know the difference between electronics and electrical. Electronics generally they will use only tin and lead. For electrical heavy PCBs and all, they will use some other extra alloying elements along with the tin and lead. And this is the solder ion. You know that it is nothing but a gun type of a thing. So here this is the portion where the heat will be generated. It is typically operated between 25 to 30 watts, and the heat generated at the tip of the thing will be around 750 degree Fahrenheit. That means 400 degrees Celsius. And the flux is very important. You know that from the first process itself, we are using the flux. So you know that what for the flux is using. So flux is nothing but a chemical composition. Generally, it is used to shield the surface where we are going to weld from the atmospheric air, and to prevent the oxidization due to the air which was present in the atmosphere. Also, this flux will dissolve and absorb the oxidized which was there in the surface. So the flux will be used for two purposes. One is for the shielding, and also to absorb the moisture or any oxidizing surface which was there in the base material. So hope you know the application. It is generally self-explanatory. So soldering is widely used in the printed circuit boards for soldering the electrical and electronic components, right? So coming to the advantages, it requires low power, low process temperature. Microstructure is not affected by any heat, because this is in between your fusion welding and the solid state welding, and this can be easily automated in the heavy industries, in the big, large scale industries and all. You can able to see the soldering will be happen in an automated manner. So that kind of a process they will call as a wave soldering. So they will place a PCB in a big conveyor. So beneath the conveyor, you will have a pool of this solder. So they will allow that conveyor to pass on to the pool of the solder, so that it will solder. So like that, we can able to easily automate the process, and dissimilar materials can be jointed using this process also. And high variety of materials may joined. Thin wall parts also be joined. These are the few advantages. Coming to the disadvantages, large section cannot be joined as your conventional welding process, and fluxes may contain the toxic components. Okay, So the fumes will be generated from the fluxes will be very harmful to the human being, those who are working on the soldering process. And soldering joints cannot be used in the high temperature applications because it is joined at lower temperature, and low strength joints, and careful of removing of a flux residuals is required to prevent the corrosion. And coming to the next part, brazing. So brazing is also a combined part. It is between your solid state welding and also yeah, in between process. So in brazing, the only difference between the soldering and brazing is in the brazing, the operation will be happen very high that means the temperature which is above to 450 degrees Celsius. In this case, only filler material melts and no the base material will be melted here. So the process is generally then the brazing operation. You will have a conventional torch, okay? So that using the torch, you will try to melt the base material. So once the heat is applied over the base material, then you will melt the filler rod on the grooves where you have to weld, right? So the filler rod will melt the material and bonded over the surface. So this is the simple process of a brazing, and this is generally used in the structural applications than compared to the soldering. So soldering is for a very simple application, whereas in the brazing it will be used for some structural application. You can able to see this is the frames. Okay, this is the frames where the frames is welded with the brasses, and also this is the joints, and this is the joints. So like this we are having a different set of applications of the brazing. So advantages, any metals can be joined including dissimilar materials, since we are going to melt the filler rod which is made up of a bronze, and certain brazing materials can be performed quickly, and brazing can be applied to thin walls. Can able to see these are the very thin wall structures, okay, thin wall parts that can be welded. In general, less heat and power is required than compared to the fusion welding. We no need of using a much high power or any heat. Coming to the disadvantages, joint strength is generally less when compared to the conventional welding. That means your arc welding or resistance welding. Also, strength of a good braced joint is greater than that of a filler material, right? So it is likely to be less than that of a base material. So we cannot apply a large amount of a force on the braced surface, and high surface temperature may weaken the brassed joints. Okay, so you have to you should not use this braced joint in very high temperature applications sometimes. And color of a metal in brass joints may not match with the color of a base material, where you can able to see the base material is of a silver color, whereas this brass is in the kind of a pale gold color. So that will be some kind of a disadvantage.